Okay, I think we can get started. So thanks for joining everyone. This is a Value in Energy Data webinar. Value in Energy Data is a series of webinars where we look at how data and digitalization is supporting the energy sector. Just a bit of housekeeping before we get started. Please switch off all microphones and video once you join the call, and keep this off for the duration of the call. If you have any questions, I'd ask you to pop it in the chat, and then towards the end of the presentation, then we'll have some time for Q&A. We're also recording this as well to share on YouTube after the webinar's finished. So yeah, kicking off, I'd like to introduce Andrew Glennie, who is a customer director at Faculty AI, the UK's leading developer of bespoke AI solutions for critical national infrastructure. Andrew oversees Faculty's portfolio of AI applications for regulated utilities and infrastructure providers, drawing on his background in regulatory economics and policymaking to bridge technical innovation and business application. With that, Andrew, I will hand over to you.
Thanks a lot, Kojo, and thank you everyone for making the time today. I will just get the slides on screen and then we can get going. All right, Kojo, just checking all good with the tech.
Yep, all good.
Excellent, thank you. Okay, right then. As I said, big thank you everyone for joining, and thanks Kojo and team at the Energy Systems Catapult for having me. As Kojo introduced, I'm Andrew. I'm a customer director at Faculty, oversee our portfolio of AI solutions for energy networks and kind of wider infrastructure, and I sit within our dedicated energy transition and environment team. Just a quick note on Faculty. So we are an applied AI company, and that means that we build bespoke AI solutions for clients across critical national infrastructure, so with a background in government, healthcare, defence, and of course energy, where I sit. And we've been very prevalent across energy networks and the system operator over the last 3 or 4 years or so, as you see from some of the logos on the slide. So in terms of today, so this talk with the catchy title is all about a specific application of AI to the energy grid and specifically flexibility. But I think throughout this talk, I'd like to cover some broader points as well throughout. So I think first of all, reporting on net zero often makes fairly vague references in terms of AI to optimize energy grids. So I think just at a conceptual level, I'll just get everyone on the same page and explain the importance of AI in net zero from a grid perspective. And secondly, I'll show that specific example and what it means in practice. So applying AI to promote use of flexible network capacity. And I'll go through an example from our work at Faculty with Northern Power Grid. And I think the last point I'd like to make throughout the talk, I think, is in this world, it's easy to get caught up on kind of like the flashy new stuff that comes up, both in an AI world, but in a hardware world as well. And sometimes it is about just doing smarter, kind of simpler things to make better use of what we have. And that's often where the value lies, in that incremental innovation. So one last thing, when I talk about AI, many definitions exist, but I quite like the fairly broad definition we have at Faculty. So defining AI as the use of computational methods or algorithms to perform tasks that typically require human intelligence, so perception and reasoning, for example, a nice and broad definition of AI. So let's get into kind of the first of those 3 points. So like AI, grids, net zero, I guess what's the challenge we have here? So to get us started, and apologies for those of you that work heavily in the industry, I'm going to start from ground up here. And here is a very oversimplified diagram of the grid. If we go from left to right, you have your generators, increasingly renewable, but historically in GB, we've of course used gas. That electricity generated is transported over long distances through the high voltage transmission lines, and that voltage is gradually stepped down as we go to distribution level, who operate the kind of regional electricity infrastructure to which you are connected to. You as a customer, of course, interact with your supplier who packages up your bill and buys the power that you ultimately use. Among all that, you of course have the system operator, NESO, who balance demand and supply on the transmission network to keep the grid frequency in around 50 hertz. The example that I'll show today is focusing at distribution level, so own and operate the grid infrastructure under 132,000 volts. So for those of you less familiar, think overhead lines, underground cables, substations where that step down in voltage takes place. All this kit that gets you connected to the electricity supply. At distribution level, there's kind of 6 companies, but 14 license areas, all in regional monopolies. And if you're in London like me, you're likely going to be with UKPN as your regional DNO. And historically, the role of these DNOs has been to safely own and operate this infrastructure as kind of gatekeepers of security of supply. But the challenges that they are now facing really kind of symbolize or personify the challenges across the grid and the wider role of AI in supporting net zero. So let's go into that a little bit. So as I said, historically, it might sound relatively simple, right? You know, they maintain the distribution network, expand as necessary as load grows, for example. But that is certainly not true in terms of the simplicity. Their role is evolving very quickly for a number of reasons. So firstly, just as a broad policy point, like to meet net zero, electrification is our broad strategy, electrification of load. So we're putting load onto the electricity network through EV chargers, heat pumps, etc., as we all know. But loads are also diversifying, right? Assets are being connected at distribution level, at the local level, that put power back onto the grid, often intermittently in the case of renewables like solar, for example. And that kind of two-way flow of power isn't how networks were originally designed. It was always a one-way flow from generators down to the customer. And all this kind of electrification and complexity requires will require a huge grid evolution in the coming years. But it's going to take time to build out that physical network infrastructure. And in those kind of short-run capacity constraints, the role of the distribution network operator, the DNO, needs to evolve into more of a system operator. So flexibly managing demand and supply across their networks to maximize utilization of their existing capacity, all while maintaining security of supply. So that's a big change from before, this new coordinator type role, a system operator, and that also requires new capabilities. But at a conceptual level, this kind of explains the role of AI both in distribution but also more widely. Like, this is fundamentally all a big optimization problem. So how do you maximize utilization of a network but subject to fixed network constraints? And this is a big challenge for all the DNOs across GB. So how can they kind of manage their networks flexibly? How can they do this kind of system operator type role? Well, if you're operating network, and this is hyper simplified for any DNO folks on the call, I mean, you've broadly got 3 or 4 options. You can kind of do nothing if you think capacity is sufficient to meet to service demand. You can reinforce, so essentially retrofit and add cabling, for example. You can build new, build a new substation, new piece of network to kind of spread the load, or you can procure flexibility, and that's going to be the topic of the example I show today. So in a nutshell, flexibility is where you're able to pay asset owners, typically aggregators who combine many units together, to shift their consumption away from specified peak periods or periods of constraint. And this is what we mean by flexibility markets. There's those financial incentives to move demand flexibly, in a nutshell. And why would we do this? Why would DNOs want to procure such services? Well, procuring and flexibly using capacity means we can buy time as we build out the required infrastructure, delaying and prioritizing network upgrades to where they're most needed. And also because it can be lowest in terms of whole life cost, a combination of flexibility and part build. But if you're going to choose the best option here and do this effectively, like as a network operator, you need the capability to have a frequently updated view of demand and capacity. And that's the capability I'll show you in the example. A quick note for those more informed, there are many flexibility markets outside of the one where a DNO, a distribution network, procures directly. So for example, the NESO demand flexibility service, like some of you on smart tariffs may have participated in that. Just for today, note that I'm dealing with an example where a distribution network, so owner and operator of the infrastructure, is procuring flexibility services directly. And I'll explain a bit more in a moment. So that's kind of like the conceptual need for AI and the realm of using flexible capacity. Now for the example of how we at faculty are looking to help in practice. So the example I'm about to show is from our work with Northern Powergrid, who's a distribution network operator in Yorkshire and the Northeast. I'll reel off some stats for you about their network. It's about 25,000 square kilometers. The map's on screen. 96,000 kilometers of overhead power lines, underground cables, and about 60,000 substations. And they've got about 4 million homes and businesses that they serve. So asset values in the billions. Like this is a significant part of our national infrastructure. The project's also partnering with 2 providers of flexibility services, and this will define kind of aggregators for you in a bit more detail. So Oak Tree Power, for example, is a flexibility service provider that operates commercial buildings or industrial facilities on behalf of their clients and can access these flexibility markets on their behalf. And EV Energy, they are an aggregator of EV electric vehicle charge points. So essentially what they're doing is combining multiple charge points together to act as a single kind of virtual power plant or as a demand side response unit and actually participate with sufficient kind of weight in these markets. So that's who. So let's go into the kind of macro problem statement, and it very much echoes what I've said before, but specific to MPG. So they're looking at significant network upgrades as we electrify, and as I said, to deal with that increasing complexity of load. And within that, they need to maximize use of flexible capacity and flexibility services. But right now, they lack the tools to do this optimally. They're forecasting quite infrequently and typically based on kind of more static load growth assumptions. They need a solution that can learn more frequently, give that updated view of demand versus capacity. So that's the view at the kind of macro level capability gap. I guess let's go down to the specific problem statement we're addressing in the flexibility space. So Northern Powergrid, they want to procure flexibility services from the market, but they also want certainty. So they need sufficient notice to help plan their networks effectively. And historically, if we look to the left, that's led to procurement being done a kind of 3 to 6 months ahead of when you actually need the service. But consider the other side of the equation, the flexibility service providers like the Oak Tree and the EV Energy of this world. Firstly, they only know their capacity much closer to the time of need. So if I operate an industrial site, a quarry like an Oak Tree, for example, like I might only know my capacity a week or a day in advance. That applies to a commercial building, a whole range of other assets. You only know your capacity much closer to the time of need. Secondly, like these aggregators or wider FSPs can participate in multiple markets. This isn't the only thing that they're doing. So the easiest example is if you're a battery operator, for example, you can participate in a range of markets like frequency response. They stack their capabilities, so dividing their capacity across different markets on these really shorter term timescales. So if they're going to participate, markets really need to move to timescales that work for the providers of these services. And historically, that's meant there's been a mismatch between the parties. And that's resulted in part in limited liquidity of these markets, limited participation. And that is a lose-lose for everyone, because the flexibility service providers don't access the revenue if they don't participate. But the DNOs then also don't get the volume of flexible capacity they need to enable flexibility as a network management solution, like I showed a few slides before. So what's the solution to this? How can we bring this together? So what the technical solution we're developing does is, as I said, at a high level provides MPG with the frequent view of demand versus capacity, and the ultimate objective being to bring that procurement closer to the time of need. It does this in kind of 3 steps at a really broad level. So it collects aggregated load data at primary and secondary substations. So recall substations is where load is monitored and where voltages are stepped down. And it does this for every substation at 30-minute windows. So at primary level, that's typically where your kind of light industry and like larger distribution generation is connected. Secondary level is where voltages are stepped down to their lowest, the 230 volts you see in your home. That's where home and businesses are connected, and kind of lighter industry as well. It then develops a forecast with this data, 30-minute windows covering the day and the week ahead at both this primary and secondary level. And it compares that forecast to the firm capacity of those substations. So it's able to identify where likely short-term constraints are going to take place. And the third step is a semi-automated part where it flags potential over capacity sites and enables flexibility engineers at MPG to validate, okay, well, the model is suggesting we have a demand capacity mismatch, that a flexibility tender is recommended. It enables them to validate kind of the metadata there and put it forward for procurement. So a human in the loop solution. And through this, you're creating the ability to procure on these more frequent timescales, something that you just couldn't do as is. You couldn't scale up effectively without this scalable technical solution. So going back to this, the micro problem statement, what the technical solution is doing is essentially acting as that bridge between the market operator, the DNO, the one who's procuring the service, and those that are actually providing it, so to create that coordination. And DNOs can still set out kind of a longer term view of where they expect flexibility services to be required and where constraints are likely to occur. But through this solution, they're able to refine flexibility service windows, so the actual time periods that the service is required, much closer to the time of use, and then flexibility service providers can then stack their capabilities more effectively. So it bridges that gap between the parties. Let's have a look at some of the kind of next level down insights. So we are ultimately here at Value in Energy Data. So let's show with that data how we're creating some value with it. So to preface this, like, what does the data that this solution uses look like? So if we go from left to right, so at primary substations, of which there are about 500 or so, we are able to disaggregate load, so power in megawatts, between the gross, i.e. consumption, with its classic periodicity, kind of 2 peaks a day structure, and export, which reflects distributed generation, like I was referring to before. The former is periodic, as I said, but the latter is often not. What you see in the middle here is a substation where there's a waste incineration generating unit associated with it. And as you can see, it's not particularly obviously periodic. It's going to be dependent on the power agreement that they have, the price, etc. But it's not a nice curved 2 peaks situation like you have with consumption. At secondary substations, everything's bundled into a net figure. Can't see much, I know, from the way we've bundled it together on the right hand side. That's periodic, as you would expect, that kind of multi-peak structure, but it's also conflated by resources that are able to put power back onto the network. And there are various models that we can use to generate a forecast for each of these components, from Bayesian approaches to the neural networks of this world, and generate a forecast. So what's the value add we're giving here? So I'll make 3 broad points. So value add 1, This is new capability that learns. These are pretty accurate models at kind of day and week ahead level in the big scheme of things, but most importantly, they're able to adapt as conditions change, not something you can do when you're forecasting annually or twice per year. A couple of level down points. So one of the value adds at the primary level, if we look at the graph on the left and the middle, as I said, we've disaggregated demand into its components, that gross demand and the export. Modeling these two separately means you can future-proof the forecast as the distributed generation component grows in future, which it will. At the moment, a lot of forecasts out there bundle these two together, and those might become inaccurate over time as the distributed generation component continues to grow. So by splitting these two out and learning the specific characteristics of each component, you're able to learn more effectively. At the secondary level, we've used clustering to improve forecasts. So as you see the chart on the right there, each cluster, if you like, represents a kind of different substation grouping. And this varies a lot across low voltage or secondary substations. On the top, you see a more traditional energy consumption profile throughout the day. This is load profiles for lots of substations bundled together on one graph. You see similar ones, as I said, with that periodic profile. And on the bottom, you see secondary substations where there's more prevalence of EV charge points. With that, it's difficult to see on the axis, but that kind of midnight charging schedule as the EVs come into effect. Applying these clusters can increase the accuracy of what we're doing. So new capability, able to learn much more frequently than existing methods, and that disaggregation provides that level down insight over and above what we're doing now. I think the value add too is this direct link to action. So you take the view of demand and capacity produced by the forecast. We have a human in the loop step where the need for a tender that results from that is validated with flexibility engineers. And then they can refine those tenders, edit as they see fit, and then input them into readily available tender portals. We're also looking to increase the level of automation in this process to minimize the amount of kind of clicks, if you like, that the flexibility engineers need to do. But broadly, it's semi-automated in nature, but we have that human validation step. And one point on this is it can work both ways. So we might identify a net new need through this process, but we might also identify times where we've kind of over forecast and where flexibility services are no longer needed. That still can benefit FSPs because they can then release that capacity to play in other markets. So it can work both ways. And ultimately, the more precise we can be in defining those requirements, the more the DNO will only pay for what it actually needs, and the more FSPs can have certainty to how they can stack their capabilities across different markets. And the last kind of value add I want to bring up is we are creating data that you can use. So as part of this work, we've developed automated kind of data cleaning pipelines for the load data, extract, transform, load, for those of you familiar with machine learning terminology. And that pipeline corrects kind of known anomalies, missing data, when load is shifted between different substations. And the output of this exercise is available on MPG's open data portal. So you can use the clean series, which presents that true view of underlying demand. So look, I will stop there. I will wrap up just with a couple of thoughts. So if we go back to where we started and the 3 points I made there, first one, kind of AI's role in evolving the grid for net zero at a conceptual level. Look, to recap, in the short run, like while we're building out network capacity, we need to make the most of what we have, maximize utilization. With that capacity constraint brings in optimization, and that implies AI and broader, smarter solutions to make the most of that infrastructure at our disposal and the flexible capacity on the network. I think that network operators, to the second point, really recognize this and the role that AI can play. I've given one quite quick example today from our work in flexibility procurement, but there are many others. So Just examples from our projects, like NISO looking to streamline the balancing process, like SSCN looking to understand the impact of connection requests on load across their network, and a read across to the gas networks, like SGN looking to accommodate biomethane within their existing gas distribution network. These are just examples from our experience. There are many more out there. And to touch on the last point, I'll conclude kind of by saying in the rush for net zero, it's great to see the new innovations coming out there from both a software and frankly a hardware perspective as well. But it's easy to get caught up in that and just focus on the new stuff, especially in the AI world. New announcements every day, new models, AI agents, the next latest buzzword at the moment. It is still possible to say AI without the gen or generative in front of it. Let's not forget to make the most of the data we have and kind of build in increments that are collectively transformative. So look, I will stop there. So thank you very much for listening. I know Kojo, you've got a few questions to open up, and then happy to take anything from the floor.
Brilliant. Thank you, Andrew, for the presentation. Found it really insightful. So excited to give you some more time to expand on a few elements. I did prepare a few questions in advance, as you mentioned, but glad to see some questions pouring through. So in the meantime, whilst I also take the cheeky privilege of asking Andrew a couple of questions, please do add your own to the chat. So Andrew, maybe continuing on from where you left off, I wondered if you could maybe elaborate on some of the examples you mentioned at the end of the presentation about how networks are looking to adopt AI within their business as usual processes.
Yeah, no problem. So I'll take the SSCM one, for example. I think that's a project under the Ofgem CIF called Fast Track. I think connection's a big theme across networks. So in distribution, the queue is about 180 gigawatts at the moment. That's a huge volume. We need to find ways of speeding up how quickly those assets can be connected. Part of that is policy and kind of regulatory design through connections reform, but part of that can also be enabled through the tech. It's a similar problem, right? You have a semi-fixed network constraint and you need to accommodate assets within that. So what that solution is doing, for example, is saying, okay, well, if I have a stack of connections at a substation, given likely behavior of those connections, what is actually likely to connect onto the network? It would be easy just to sum everything up and plan for that eventuality, but actually what we've seen is some are speculative, some will drop out due to transmission constraints, some will drop out due to planning issues, for example. If we can really unpack the behavior of different requests in the queue, you get a much clearer picture of what load is likely to be across your network. So that's just another example of kind of simulation forecasting type adoption that these networks are really keen to adopt.
Brilliant, thank you. Speaking of the accuracy, I wondered if you could maybe talk a bit about how the accuracy improvements or the accuracy of the model overall, how that translates into actual cost savings when DNOs are making real-time flexibility procurement decisions.
Yeah, so accuracy is an interesting one. Like, you of course want forecasts to be as accurate as they can, but there's no kind of absolute benchmark here. Simply that the more accurate we become, the more specific DNOs are able to be with their requirements, and the more certainty flexibility service providers have into which market they want to play in. And ultimately, that means that you'll only pay for what you use, and also creates revenue opportunities for FSPs and other parts of the market. So if you like, there's a kind of fixed benefit and a variable benefit in terms of its new capability, right? You wouldn't be able to procure on very much shorter timescales without this capability. So there's kind of a fixed benefit, but there's also that variable benefit that scales as the more accurate you can be.
Thank you. I'll ask a couple more and then I'll choose some questions from the chat. So you mentioned that the solution is designed for replication across other DNOs potentially, or at least other DNOs can utilize it. I just wondered, what's been the biggest barrier to adoption that you've encountered, and how are you addressing any possible concerns around integrating AI-driven forecasting into existing processes? Obviously, the energy sector tends to move quite slowly with things, so I'm just wondering if you've encountered many barriers in that process.
Yeah. No, that's a good question. I think the first thing to say is that there's a high bar, I think, across networks for these types of solutions. Like, these are these are highly skilled organizations when it comes to forecasting and physical modeling, right? They're required to forecast from an economics and business plan perspective, but also from a power systems perspective across their business. So these are highly skilled organizations. They know their networks inside out, and there's, as a result, a very fair kind of high bar for AI solutions to come in. But I think how we like to do it historically, and what we've seen work, is firstly showing how the solution will kind of augment capability rather than replace. We're very much in a kind of human in the loop, maximize value of expertise worlds in how we typically build solutions. I think the second thing is trying to show people very early on what they'll get at the end and how it will help their day job. So even if it's an interface that isn't final yet, actually being able to play with something, understand, you know what, if this was built, I can see how I would click through from a forecast and output through to a tender is really, really helpful. So just a couple of things there that have helped. I think last thing to say probably is with the MPG project, it's kind of highlighted the role of or the importance of good governance. So defining kind of who is going to be maintaining the solution after the developer is gone. Is it the developer themselves, or is it someone within the network? Who is going to be monitoring the performance of the solution, therefore needs to understand what it's doing at a technical level in terms of the data science. And who doesn't necessarily need to know how it works, but needs to use the outputs. Like dividing these roles and responsibilities in terms of good governance is a helpful way to promote adoption as well.
That was really insightful. It gave me. There's a few more questions I'd love to ask, but perhaps I will choose from the crowd and then maybe come back to my questions afterwards.
Sure.
So sticking with security, there's a question from Tara Ryan. Have there been any barriers around the concern from security risk with the amount of data required to feed into the model? And how have these been managed to prevent stalling innovation and the value from these projects?
Yeah, that's a good question. I think on MPG, I think we are blessed a little bit by the fact that much of the core data set we use, the load data, is made available publicly anyway. So we don't have the same kind of confidentiality or even kind of like issues like personal data you typically run into on these types of projects that others might run into. So from a security perspective, we of course need to have the right guardrails and access in place for the users, but I think we have an easier time of it compared to some other solutions across the energy networks. And can you repeat the second part of your question, please, Kojo?
It says, how have these been managed to prevent stalling innovation and the value from these projects?
Yeah, I'd finalize just by saying I think the barrier there is less around security. It's more around how quickly can we get monitoring across the full network. So DNOs are at different stages of this, but kind of monitoring at low voltage, so the secondary substations, is kind of being rolled out. Not every substation has monitoring equipment that can give this kind of high frequency information that we need. So the challenge, I think, is how quickly and to what extent do you want to roll out that capability across the network to really have visibility about what's going on, as opposed to the security angle.
Okay. Got a question from Sam from the Energy Systems Catapult. So looking more towards the development of the actual solution, from a skills perspective, what was the background of the team that worked on this? Was it AI generalist, or did it include people who are already specialists in energy load forecasting? And then an additional part to that is just, what's your thoughts about the ideal mix of skills working on these kind of problems?
Yeah, good question. So I'll divide it into kind of like faculty side and network operator side. So like faculty side, we have dedicated business units for a reason, because the type of problems that come up in different industries, they tend to persist. So we have built up a kind of internal expertise in things like power systems modeling. I'm not going to say we're all power systems engineers before I get that comment in the chat, but I think you really do, by developing some of these solutions, get very technical very quickly with some of the underlying data sets and the techniques you can use to produce a forecast or optimize, for example. So from faculty side, all the teams are multidisciplinary. So you'll have, of course, data scientists, machine learning engineers that essentially turn the solution from a model into repeated software. But you also have commercial folks like myself who act as the bridge between technical and commercial, both internally and with our clients. So we always have that a kind of multidisciplinary skill set. From the network side of things, it's been, as I touched on with some of the governance, it's been a mixed team depending on the role and responsibility that they need to have. So system forecasting and data, NPG's internal data science kind of capability have been the main drivers from a technical perspective in terms of the methods and validating performance. Is it good enough? But the end users have ultimately been the flexibility engineers who will use the outputs for tendering. So I think in terms of like the ultimate kind of ultimate mix, I do believe that in this kind of multidisciplinary model, like I'm biased because I'm one of them, but I think the key role, even if you don't have any interest in knowing the underlying technology or don't feel you have the skills, if you can be that kind of translator between technical solution and business need, you're going to be highly effective in whatever job you do. So I kind of highlight that role as something that people that might not be a data scientist by trade can really get very good at very quickly.
I very much resonate with that. Somebody who's not a data scientist by trade when working in this space. So yeah, thank you for that. Next question here from Brendan. What level of active flexibility are you building in your initial modeling, i.e. potential demand side flexibility versus reliably achieved flexibility to avoid user flexibility fatigue?
That's a good question. Let me try and address. I think one thing we're trying to do at the moment is in building kind of existing tenders that have taken place and kind of impute that knowledge into how the forecast is generated, so you're only getting a picture of underlying load, and then using kind of future tenders as a forecast input. So we are trying to actively account for that, for those kind of ongoing tendering. I think one thing to say is that like DNO markets are relatively nascent at the moment in terms of like liquidity and number of tenders that go out. So this is very much kind of a future targeted solution in a world where many DNOs are looking at kind of 3 to 5x like reinforcement investment in the next price controls. There is going to be by that fact alone, there is like a clear need for flexible capacity. So it's very much kind of forward looking in terms of the number of tenders that are likely to go out in future. I might not have answered fully the question there. So please put in the chat if you want any follow up.
Cool. I want to jump to a question from Sam above, which says, when doing the forecasting, how do you account for the effect of flexibility that was procured during the period covered by the training data, and do you back that out of data before the training forecast?
Yeah, good question. Yeah, so I think that's what I touched on. I think so. In the past, there haven't actually been that many tenders, so the overall impact on the load series has been relatively negligible, which helps. But yeah, as I said, we are looking to input into the forecast. Okay, what tenders have historically been like our training, like our ETL pipeline, able to strip out anything that isn't kind of a view of core underlying load, but also then use information from the flexibility tender portals as input to the forecast as to what we expect on the demand side. Best way of doing that from a technical perspective, still trying to work out how best to kind of ingest that in a kind of live way, but that's the theory anyway.
Thank you. Okay, I'm going to ask a question myself, which is that the solution, it spans from EHV primary substations down to like high voltage, low voltage secondary substations, which is a massive increase in assets to monitor and coordinate potentially for the DNOs. How does the solution that you just discussed, how does that help DNOs manage the complexity? Do you anticipate that they need to upscale their teams significantly to procure flexibility resources, or is there an element of automation in here which will help maintain overhead?
Yeah, I mean, fundamentally, I think volume of tenders is likely to increase, but you're able to do more with what you have at a really high level. In terms of managing the complexity, I mean, fundamentally, what you're looking for in these markets is kind of a block of capacity, and if you're procuring a primary, for example, if the physics adds up, that can be met by any asset kind of below that level. So what we really need to give flexibility engineers is just the metadata and the outputs they need to then create that tender. So there's no, I guess, say added complexity from that side. But from the scaling perspective, I think it's about doing more with what you have, but there's still likely to be some level of increase required in future because of that volume, because of the kind of dynamism that you're now doing it at.
Thank you. I've got a question here from Nicholas, which said, I noticed in your slides that you integrate with Piccolo Energy. How does that integration work? Is there a man in the middle who participates?
How that is a very astute observation. I tried to cut out all the logos from the screenshots, but I guess you've used the platform before and therefore are familiar with it. So other flexibility platforms are available, I should say, others like Electron, for example. Many of these platforms have kind of APIs that you can access directly from a technical standpoint. So that automation can in principle be developed. Now, I think it's in their interests to enable that, because the more they can enable that integration, the more volume they could potentially get through their platform. So it's certainly in their interest to open that up. Each platform has a slightly different way of doing things, a slightly different level of openness, but in a broad sense, they're incentivized to provide access, and we are looking to enable that kind of automation where once the engineers have validated the need, it's kind of a click away rather than too much manual input.
Thank you. I'm going to scroll. There's another question from Nicholas here related to the sector. So sort of relates to what I mentioned earlier, with the energy sector being so conservative and generally slow to adopt new technologies. What do you think is the key element that allowed bringing to application these data-orientated innovations?
In terms of like the key things that turn a kind of concept into a like a deployed solution.
Yeah, I guess it's really trying to drive at what's caused them to want to embrace like these like AI-driven solutions, typically where the sector's quite slow.
Yeah, okay, that's a great question. I mean, fundamentally, it's kind of everything comes down to economics at the end of the day. Like in the same way that integrating renewables into our energy mix, like the economics is fundamentally driving that as a cheaper producer of energy. I mean, different context here, but the economics is very much like, you have fixed capacity, you're going to have increased risk to your network, therefore you must be smarter at managing your existing infrastructure. And there are, of course, kind of like physics-based or kind of hardware-based solutions out there, but one way of doing that is solutions that AI can provide, right? Doing, optimizing across multiple units, like trying to develop a physical representation or computational representation of the network. Like the need is fundamentally an economic one. So we have the incentives are all aligned to try and build in these smarter incentives, these kind of smarter solutions rather. What I would say as well is that for those of you less aware, like the regulator and UKRI have a very strong role in promoting innovation across the sector. So through their strategic innovation fund, like they are actively setting out challenges for networks to adopt these AI solutions that might otherwise be or try out developing AI solutions that might otherwise be too risky under business as usual. So there's a combination of kind of like the economic driver, but also the support from government and regulators.
Thank you. Another question from Sam. How well does the cleaning/forecasting process cope with switching actions that move load from one substation to another?
Yeah, it's a good question. I will have to refer you to our technical guys as to how well it performs. But in general, because you have quite clear knowledge and kind of labeled data sets as to what was transferred and when, you are able to remove quite effectively. And the series that come out of that ETL pipeline are sensical. One way you can test how much sense I'm talking is you can download the output yourself to have a look. But I'm happy to have a follow up with the technical team we have to go into a bit more detail on how that works if you like.
I will take the liberty of asking a question myself, which is I'm curious about actually the flexibility service providers, and basically I guess their perspective on the solution. That are you seeing much resistance or enthusiasm from them? Because obviously we're moving from the I guess the default, which is a 6 month ahead tenders, to more like day week ahead procurement. So yeah, can you elaborate on maybe their perspective on or some of the perspectives you heard around this from FSPs?
Yeah, sure. I think DNO kind of procured markets are, I think, in a world of catching up with other kind of flexibility markets. I think when we did some market engagement with wider FSPs, it was often perceived that the DNO markets are kind of like cherry on the cake, but kind of like a nice to have rather than considered as a really core market to play in. And part of that was because of the timelines that they were procured on. Often when it comes to enthusiasm and whether they're driving this, like broadly, yes, there is a drive to move to these more shorter term timescales where they know their capacity and are able to stack their capabilities across multiple markets. Like as I said, like the battery example is the easiest. Like with NESO kind of frequency response, that market is day ahead. So batteries are already like well versed in responding to kind of day ahead and intraday incentives, but they don't really participate that much in DNO markets as is. So FSPs have really been the one kind of pushing the change on this one, and there's already kind of familiarity with much shorter term timescale markets. And DNOs are certainly on board as well because they want to maximize the options at their disposal. And I think the last thing I'd say is I think a lot of work has been done by DNOs in this space. So some have kind of scaled up existing capacity, some have sought to kind of go out the box. But there is, regardless of how they've done it, like there is a broad move towards shorter term tenders, and I think some have now gone to monthly and potentially weekly as well.
Thank you. I have two final questions for you, Andrew. Maybe we check if there's any more from the chat. One of them really is just how do you ensure that the solution has accurate, up to date information? Obviously, I know in one of the slides you had the MAP, the percentage points of accuracy. But yeah, can you just expand on how that's how you ensure accuracy of the data, but especially because there's a number of partners involved. Obviously, looking at aggregators, asset owners, up to the DNOs. So what does that accuracy look like?
Yeah, it's a great question. I think, and as you saw in those slides, like part of the challenge is trying to model like the export component directly is non-periodic. There's a number of factors that can drive those patterns. In terms of keeping the forecast up to date, like we envisage that this will be retrained monthly. So I guess a lot of solutions are potentially only go to kind of quarter level, but we're looking to retrain this monthly. Core data is readily available, so I think that will strike the balance between enough happening and things being connected and load profiles changing, that there's enough happens that you need to learn from, but also high frequency enough that you're not missing big step changes in the network. Of course, you can manually retrain it as well if there's a huge like fundamental shift in the underlying load that's connected. So that kind of retraining really helps you keep data up to date. I say that one of the big challenges we're going to have is, as I mentioned at the secondary level, the extent of low voltage monitoring. So the kit that can provide the high frequency data with that quality is still very much in full swing, that rollout. So what we're going to have to do at secondary level is scale quite a lot from the, say, like 1,000 substations we might have now to 10,000 and then more in future. There's about 60,000 substations on the network. So you can see the potential challenge in scaling this. And as you scale it across a wider sample, there's of course going to be different profiles that you may not have seen before, or different archetypes that come into that. So that'll be the real proof in the pudding as to how well we can adapt for new information.
Thank you. My last question, actually, you kind of already began to allude to, if I'm honest, but maybe I just say it anyways and kind of give you the platform. But I wondered if you can elaborate maybe on what success looks like for this solution. What's the next steps for it in terms of what you think, how big it can grow, additional users. What do you think the next steps are for the solution?
Yeah, it's a great question. So in terms of the program, it's being deployed at the moment, and it's because it's dealing with multiple levels. It's going to be a multiple year program, so it's going to be finishing next year. I think fundamentally, like success factor one is kind of the adoption and use in these day and week ahead kind of flexibility windows over and above obviously the baseline, which is 6 months ahead of time. So that kind of tick box, like have we managed to actually provide capability that is trusted and used on a day-to-day level, is obviously like the big kind of core success factor. As I mentioned, like accuracy is really difficult to quantify as a kind of absolute metric, but the more we can hone the performance of these models in the time we have, the more specific and also, I guess, more trustworthy it's going to be. What I will add as well is that a lot of work's going into quantifying the uncertainty associated with forecasts as we build out. So, you know, you can build trust by having an accurate single line, but you can also build trust by having a reasonable range around it that people understand and can interpret. In terms of like success for the wider program, I think, you know, we don't want this just to be a Northern Power Grid solution. They're certainly on board with that as well. Like it has been designed from a technical perspective quite deliberately to be modular in nature. So you could just take the ETL pipeline element as a standalone. You can take the modeling element as a standalone. Like you can you know, if you're looking to adopt this in future, it can be done in that modular fashion. So success for us is really expanding the use of the solution across the industry, because the more dynamic we can make these markets, the more of an option flexibility is going to be.
Thank you. Yeah, very much agree with the sentiment you ended on. Yeah, I think without, you know, wonderfully put, we could draw to a close there. Andrew, do you want to maybe just share how people can reach you if they wanted to speak about this further, or had any thoughts or questions or comments?
Yeah, please do. As I said, we'll share the details with the slides, which has got all my bio and email, etc. After this session. Obviously, I'm on social as well, LinkedIn, for example. So do drop me a message if you're interested. But most of all, thank you for spending your sunny lunchtime listening to me. I do appreciate it.
Thank you, Andrew. Okay, so we'll draw to a close there. As Andrew said, the webinar will be made available online as well as the slides. And yeah, definitely encourage you to connect with Andrew and faculty. So thank you very much for your time, and see you soon.
Thanks, Kojo. Thanks, everyone.